Good afternoon, boys and girls, on this rainy Thursday afternoon. I just wanted to take a moment of your time to review some concepts that we talked about on Google Meet today. Yesterday, I introduced you guys to quadrilaterals, and we added some examples to our notebook. Today, you guys did some assignments for me, and I could tell that the trapezoid was a little confusing. So I just wanted to really quickly talk to you about how the trapezoid is different from the other quadrilaterals that might be in your notebook. So a trapezoid is a quadrilateral because it has four sides. That is the easiest attribute for all of the quadrilaterals. They all have four sides. But what separates one quadrilateral from another is going to be based on the other attributes like pairs of parallel lines and angles. So I want you to take a look at the two trapezoids that are on this page. You will notice that they both have four sides. 1, 2, 3, and 4. 1, 2, 3, and 4. Both have four sides. But as far as parallel lines moving in the same direction, never intersecting or crossing, if you take a look at the top and the bottom of this first trapezoid, that is one pair of parallel sides. Moving over to the next trapezoid, you'll notice though the lines aren't the same length on both of these trapezoids, they are parallel. The top and the bottom are parallel. So all trapezoids have only one pair of parallel sides. When you look at the other lines or the other sides on a trapezoid, they are not parallel. If I had my two drumsticks or my two fingers or my two pencils and I were pointing them in the same direction as these sides, eventually those two pencils, those two fingers, those two whatever it is you have would eventually touch across. So they are not parallel. And that's what separates the trapezoid from the other quadrilaterals. So just a quick review, just so that you don't get confused on what separates the trapezoid from the other quadrilaterals. Okay. Another thing that we spent some time talking about was a new concept in science that you're studying, and it's actually perfect for a rainy day like today. At my house, it's been raining since the moment that I woke up, and outside my window, happening right there, is weathering and erosion. So weathering and erosion are two very common science concepts. And though they may seem to clump together, they are very different. So weathering is actually the breaking down of rocks and soil. You can't move it unless it's been broken down. So if you look at the picture on the left here, here's a rock, once solid in one piece, and you can tell that that rock has been weathered. Pieces of it have been broken down. Well, what caused that rock to break down? It could be strong wind. It could be the movement of water, and it can also be water that has frozen and turned to ice. When water freezes and turns to ice, it expands and the material around it is broken apart. So once we have the breaking of material down, whether it be wind, water, or ice, erosion comes in next, and it's able to move or carry the material away. So here we see the pieces of the rock that were broken down. We see that the rain is falling and the water is moving, and because it's been broken down, it's so easy for it to be moved away. I found a silly song after our meeting, and it really gets you thinking about the differences between weathering and erosion. They really focus on weathering breaking it down and erosion moving it. So that's a great resource if you want to listen to it, and I will have that posted on our stream. And then we also talked about some real world examples of weathering and erosion. Some of the most beautiful landforms in the world would not be possible without the forces of weathering and erosion. So just a question for you to think about as you look at this picture. What did this rock originally look like? If we could zoom back in time 500 years ago, would it look like this? And how or why did it change? Just something to think about. Moving on, another picture. If you take a look at the ground in this picture, you can see that there are many openings in the ground, and filling up those openings are puddles. Well, how do those openings get there in the first place? can't have a puddle form without an opening in the ground. And that opening can only be formed in certain ways. Think about that. Here's another picture, a place where many of us wish we were during this time of the year. You'll notice that this beach is empty, kind of like a lot of beaches in our area. Something to think about the next time you're at the beach, or when you think about a trip that you've taken to the beach, is what happens to the rocks on the beach every time those waves come in and crash? When the waves crash, what happens? And what happens when the waves go out? And I want you to think about how that happens constantly, all day long at the beach. So do the rocks break apart when the waves crash? How are they moved? And does this happen constantly? I'm willing to bet that these teeny tiny rocks used to be way out here in the ocean, and they also used to be much larger. I believe I have one more. Oh, this is just another example of a much more powerful wave crashing. Just something to think about, that rock that we can see exposed, and what happens when a forceful wave hits that rock, and what happens when the waves go back out. And oh, this was really cool. At the very end of our discussion, we talked about plants. We kind of forgot about plants until the very end, but plants are powerful. The roots of plant are weathering the rocks and the soil around us. So here we can see a big, beautiful rock that was broken simply by the roots of this tree that were trying to grow and survive in the soil. Blue Ridge, if you ever noticed, our parking lot was pretty rough. There were pieces of it that were broken and falling apart. Part of that is weathering, okay? This photograph is actually a picture of a famous tree that's in Greenville, South Carolina. There's a beautiful park there called Falls Park, and what draws people to this tree is simply the fact that all of its roots are exposed. They are barely clinging to the remaining land and rock that's left behind. Guys, a long time ago, this was all covered. Those roots were not exposed. Think about how we're able to see them today. Do you think a person did that, or do you think Mother Nature did it just with its natural process? So again, just some things for us to think about as we're moving through our study of quadrilaterals and our activities and studies of weathering and erosion. I hope this helped. If you have any questions, let me know. Have a great day.